Welcome back to the Network Plus training series. 2 lessons ago, we did cables, the layer 1 stuff you can see. Last lesson, we did wireless, the layer 1 stuff you can't see. Now we go up the stack, services, the stuff that looks like the whole network is broken when actually it's one box doing the wrong thing. Objective 5.4, common network service issues. The classic "the internet is down" ticket that turns out to be DNS, the "I can't connect" ticket that turns out to be a stale DHCP lease, the "everything's broken" ticket that turns out to be NTP drift, causing certificate validation to fail. Service issues live above the wires and below the apps, and when they break, every user in the building feels it. Let's start with the most common service failure, DNS. Here's the symptom every help desk hears 5 times a week. I can't reach this website. You ping the website by name, fails. You ping the same site by IP address, works. Congratulations, your network is fine. Your DNS is broken. By name fails, by IP works. That one symptom locks in the diagnosis. Common DNS problems. Unreachable DNS server. Client points to a server that's down or unreachable. Misconfigured records, wrong. A record, wrong CNAME, missing quad A. DNS cache poisoning. The cache was tampered with and now resolves to attacker-controlled addresses. Slow resolution. DNS server is up, but heavily loaded or doing recursive lookups across the internet. Use NSLOOKUP or dig to test the server directly. If those queries fail, it's the server. If they succeed, the client is pointed at the wrong server. Now DHCP, the service that hands out IP addresses. When DHCP breaks, the client can't get an address. And the smoking gun is APIPA. If a Windows client can't reach a DHCP server, it falls back to APIPA, automatic private IP addressing. The address comes from the 169.254/16 range. If you check ipconfig and see 169.254.anything, that machine never got a DHCP response. Either the client can't reach the server or the server can't respond. Common DHCP problems. Exhausted address pool. Every address in the scope is leased out. Verify scope size. Check for stale leases. Rogue DHCP server. Somebody plugged in a router and now half the network gets addresses from it. Wrong scope. DHCP server is handing out addresses for the wrong subnet. Relay broken. The IP helper address on the router is misconfigured, so the requests from a remote subnet never reach the server. Each one shows up differently. Check the leases on the server first. NTP, Network Time Protocol, the unsexy service that breaks everything when it drifts. When NTP fails, clocks drift. When clocks drift, certificate validation breaks. When certificate validation breaks, TLS handshakes fail. When TLS handshakes fail, applications stop working. So NTP drift looks like a TLS problem, looks like an application problem, looks like the whole internet is broken. Always check NTP early. NTP troubleshooting checklist. Confirm devices point to a valid NTP server. Confirm port 123 isn't blocked at the firewall. Confirm the server itself is synced. A Stratum 1 server pointing at nothing is just a sad clock with delusions. Watch the offset. Anything beyond a few seconds and authentication starts failing. VLAN assignment. If a device is in the wrong VLAN, it can talk to other things in that wrong VLAN, but it cannot reach what the user expected. Verify the switch port's VLAN assignment. Verify trunk configuration if the VLAN crosses switches. Check the native VLAN. Mismatch native VLANs across a trunk silently drop traffic. And remember access ports versus trunk ports. An access port forced into the wrong VLAN is invisible until somebody runs show interface status. Routing. The user can talk to the printer down the hall, but can't reach a server on a different subnet. That's a routing problem. Verify the default gateway on the client. Verify static or dynamic routes on the routers. Verify the routes exist on both sides. Asymmetric routing, where traffic goes one direction but can't return, is one of the most painful failures in networking. Firewalls and ACLs. The "it was working yesterday" classic. Service stops working. First question is, what changed? Did somebody push a firewall rule? Did a security team tighten an ACL? Did a port go from open to closed? ACL order matters. Top down, first match. A new deny rule above an old permit silently kills traffic. Check the rule change log before anything else. Performance issues are the slow burn kind. The service still works, just badly. 3 metrics dominate. Latency, round trip time. High latency means slow response, caused by congestion, overloaded devices, or suboptimal paths. Jitter, variation in latency. Catastrophic for voice and video, caused by buffer mismanagement, queuing, intermittent congestion. Packet loss, packets that simply never arrive. Catastrophic for everything, caused by congestion, hardware failure, or a bad cable somewhere on the path. Certificates, the expired cert browser warning that everyone clicks through. Expired, the certificate's validity period passed. Mismatched, the certificate's name doesn't match the host name. Untrusted CA, the issuing authority isn't in the trust store. Revoked, the cert was pulled, but the client doesn't know yet because OCSP is broken. Renew, replace, or reroute, depends on which one fails. Email service issues. SMTP for sending. IMAP and POP3 for receiving. MX record problems on the DNS side. Spam filter blocking legitimate mail. Wrong server settings on the client. Email is just TCP traffic to specific ports. If you can telnet to port 25, 143, or 110, the network is fine and it's the application's fault. Systematic troubleshooting for service issues. Start with scope. Is it one user, one floor, one site, one service, or everyone? Then isolate the service. Can the user reach other services? If yes, it's specific to that service. If no, it's broader. Then isolate the component. Is it the client, the network path, the server, or a downstream dependency like DNS or NTP? Then check logs in that order. Client first, network second, server third, downstream last. The tools you'll reach for. NSLOOKUP and dig for DNS. Ping for basic reachability. Traceroute for path. APIPA and ifconfig for client config. Netstat for connections and ports. And on the device, show IP route, show VLAN, show running config. The CLI tells you what the GUI lies about. Quick recap. DNS, by name fails, by IP works. DHCP, APIPA at 169.254 means broken. NTP drift breaks TLS, breaks everything. VLAN, routing, firewall, start with what changed. Performance, latency, jitter, loss. Certificates, expired, mismatched, untrusted. Always start with scope, then isolate. That is Objective 5.4. Next up, Objective 5.5, the tools and protocols you'll use to actually solve all of this. Ping, Traceroute, Wireshark, the full kit, the series finale. See you there.